Well, hello everyone. I'm Lucy from Upstage. I want to share a bit about how we're transforming work with LLMs and document AI. It's really great to be here. So, yeah, many of you might not have heard of Upstage, so let me give you a brief introduction. We're a enterprise AI startup based in Seoul and the San Francisco Bay Area. We're originally based in Seoul and currently expanding to the US. That's probably one of the reasons, if you have not heard of us, that's probably the reasons. But in Korea, we have a lot of customers, including Samsung, Intel, Hyundai, Hanwha, and so on. We're currently in our Series B. Our flagship products are LLM and Document AI when we serve SMBs to enterprises in finance, legal, bio, and more. And I'd like to share more about our story. So, our mission at Upstage is to build intelligence for the future of work. And let me ask you a question. How do you imagine the future of work? So in the next slide, I'm just going to ask you this question and wait for like 5 seconds because you probably um, need some time to think about this. So a lot of people say, um, if we go to the next slide, that a lot of a collaboration between artificial intelligence and humans will occur, and we totally agree to that view. Machines will automate repetitive tasks. Machines will generate insights that support decision making. Humans will be the last approval to make the decisions, and this will eventually make organizations more productive. And if we go to the next slide, we work with a lot of insurance companies in Korea. And we actually observe this from a lot of our customers. A lot of our customers are asking that we should probably automate insurance claims adjusting. For example, before, when we got a lot of documents from customers, I mean, when they apply for a insurance claim, the documents get digitized, and then humans validate the documents. Humans assess the documents. Humans adjust the final insurance approval. And finally, someone makes a decision of how much we're going to provide the customers of the insurance amount. But a lot of our customers are saying, "Hey, can't we do this with an agent?" We're calling that agent Charlie at the moment. Uh, Input the documents, and then with Charlie, from digitization to adjustment, can we do that all in one? Since now we have the power of LLMs, and probably there can be a human that makes the decision. And we totally agree with the view of our customers, and we're trying to make this adjuster internally. And that made us think, what do we need to build this adjuster? So we decided internally we need two things, language processing and document processing. So for language processing, we think LLMs, powerful natural language processing engines that require minimal supervision and has reasoning capabilities. The second is document processing, where a lot of we can pass the complex documents to LLMs. So that's why we build in the next slide. Um, the Solar LLM family, and document parse. So let me briefly introduce these two products in the next slide. So to go first with Solar LLM, we have two lineups, Solar Mini, which is open source, Solar Pro, which is uploaded in AWS Marketplace. So Solar Mini, as Michael introduced, is one of the most good models for fine-tuning. Solar Pro is the one of the most intelligent LLMs that can go on a single GPU. And you might be wondering, hey, there are so many LLMs out there. Why do we need another LLM? Let me just tell you more about that. So Solar LLMs are purpose-built for the workspace because I told you that Upstage is very interested in solving workspace problems. We're building work intelligence. How we try to build them so that they are first extremely fine-tunable because we believe that small LLMs can have an edge when they are fine-tuned. The second is we want them to be strong in handling structured inputs. Because as I told you before, document processing is very important. And when we convert a lot of those documents into structured inputs, we believe they can be processed by these small LLMs. The third is since we value workspace intelligence, we make these models very strong in finance, legal, and healthcare. And as you probably know, a lot of our enterprise customers are very cost sensitive. So we try to fit everything on a single GPU, yet be so powerful. So let me touch more about the extremely fine-tunable part. So Predibase hosts multiple LLMs for fine-tuning, and one experiment that we did together in June 2024 was that Solar Mini won 50% out of 31 tasks compared to 13 different fine-tuned models, including GPT-4. So as you can see in the graph on the right, Solar LLM is winning more than half of the tasks. And Solar Pro, which you can see in the table below, is still ranked as the number one model for fine tuning. So we value this very, very much. Our enterprise customers click on this feature very, very much. And we think this is a very important part. The next part is it should be strong in handling structured inputs. So Solar aims to be strong in handling structured data such as HTML. And compared to other models, Solar Pro is one of the strongest in understanding HTML. It is very similar in terms of GPT-4o and surpasses GPT-4o Mini, especially in understanding tables. The next part is it is very strong in finance, legal, and healthcare. We think this is very important. We still need a little bit of work to do in this area, but we still pursue that domain expertise is very, very important for our customers because understanding finance is very important for finance customers. But understanding entertainment is not as important as much. So we want domain expertise in that sense. But actually, I want to stress the second part a bit more. A competent LLM is not enough for our enterprise customers. Much of the internal knowledge is locked in complex documents that have multiple columns, including complex layouts, multi-page. I'm talking hundreds of pages, not just 3 or 4 pages, and they're very visually rich, meaning that a lot of complex tables and figures are included in the documents. So that's why we build Document Parse. Document Parse aims to convert complex documents into LLM readable formats like into HTML, or it can convert into Markdown, and it can input JPEG, PNG, BMP, PDF, PPTX, and whatnot. And what we aim to do is it should be very high accuracy, yet blazingly fast. So internally, we did some experiments to check whether it's actually high accuracy and blazing fast. But one of the things that we realized is that there actually isn't a benchmark for this task. So we built a document parsing benchmark called DP Parse, and it includes 200 English documents, and we try to measure accuracy and speed for element detection and serialization, table structure recognition. Let me introduce this part a bit more. So element detection means that we want to accurately detect the elements within the documents, say a table or images or a paragraph, headings, footers. And so we call these elements. We want to detect where these elements are. And second, we want to serialize these elements so that they can be listed in human reading order. So say you have a PowerPoint slide deck that consists of tables, images, paragraphs, and so on. We want to make the elements most very ordered in a very humanly ordered way so that machines can understand the semantics and be passed on to LLMs. The the second part is table structure recognition, where a lot of the tables are very, very important and very complex. I will show you an example later on. And a lot of our customers in finance, particularly, are very interested in tables. So we value table structure recognition very much. So passing on to that, let me show you some experimental results about the accuracy. TEDS is the table structure recognition metric. NID is the reading order metric. You can see that Upstage is very similar to AWS in terms of NID, in terms of reading order. But the TEDS is about 93 compared to the second ranking product that is 88, which means that Upstage document parse is very strong in table structure recognition. And I'd like to touch upon the next part where the average time is very small compared to competing services, which goes to average time at 3 seconds per page. But I don't just want to talk about one page because I told you that a lot of the documents are not just 3 or 4 pages. It goes to hundreds of pages. We've seen a lot of documents that go to thousands of pages. So let's go to the next page and see how, oh, sorry, the arrangement is a bit different. So this is an example of the table structure recognition. And you can see on the right, on the example has merged headers, hierarchical headers. It has some empty cells, which a lot of the machine based models struggle a lot in understanding. So we tried to solve this problem very, very intensively, and you can see later in our demo yourself and input your own documents. So going to the speed part, let me touch this a bit more. This is the average time per document. So if you see on the x-axis, it says the page range. So on the left, 0 to 1 pages. On the right, it's 51 to 100 pages, which means that if you actually have a very naive process, the more pages you have, the system will take exponential time or linear time, and the time will grow exceedingly fast. So a lot of the services or open sources out there actually do show exponential time. But if you see document parse, it is very linear. And when you take care of a document that is 1 page, it's 3 seconds. 100 pages, it's 30 seconds. So a lot of you might be wondering now, there's so many multimodal LLMs out there. Why should I use document parse when I could just use a multimodal LLM? So I can tell you about 3 things. First is speed, as I just said right now. If you have a 100-page document or a 700-page document, then document parse is one of the options that you want to consider. Accuracy. We've seen a lot of hallucinations in multimodal LLMs. If you want to convert your document with very high accuracy without hallucination, then this is one of the options you want to consider. And interpretability is another reason, because sometimes you want to index intermediate results, maybe for speed or accuracy, or probably for other options such as analyzing the data. So yeah, that's about it. And while we explore our workspace intelligence building, we built Solar LLM and Document Parse, and hopefully these two will help your journey on improving your own work. Thank you so much.
As Michael mentioned, I'm Siddharth Ghatti. You can call me Sid. I'm working in enterprise architecture for Marsh McLennan. Uh, we actually ended up using one of Upstage's products, the Solar Mini, for kind of to start our product-based journey as we kind of walked in, and it's actually one of our production use cases at the moment. So I don't know if you guys were on here for the call earlier, but we have a personal assistant within the firm. We call him LenAI. So I can go ahead and share my screen, just kind of give a brief overview of our use case, which is currently actually in production. So uh, if you guys can, yeah. So if you can see my screen, basically what we have as part of this use case is we have what we call, as part of LenAI, we have essentially an internal list of tools that we use to essentially enable productivity for our colleagues. These tools are internal applications, internal APIs that we hook into LenAI, either through function calling or directly calling them. As we kind of expanded the list of tools we had over time, we needed something to kind of route based on a user's query, the best tool that they could get. So we built what we call the router, the tool router. Initially what that was essentially a 3.5 function call that would take in, when we were on GPT 3.5, that would take in the list of tools based on the user's query, figure out which tool to call, and then we would then make that call to get the tool and get the output. As we increased the list of our tools over time, we saw 3.5 start to break a little bit, and that's when we started working with Predabase. So the high level kind of architecture here of the sequence is user request comes in into LenAI. LenAI then makes a call to our adapter that we have hosted within Predabase to essentially get which tool is best specified for this request. We then, if it's based on the nature of the tool, we can either directly call the tool, or we have to make a function call to get the parameters needed to call the tool. So then based on the tool, we either make a call to our internal OpenAI proxy to get the tool specifications, and then make the call to the tool and return the response, or directly call the tool. As Paul mentioned, this use case is currently in production. We have about half a million requests that go in per week. On every single request, we call the router. So it's pretty performant. And to kind of give an illustration of it, I have running locally a very limited version of LenAI. I can't obviously run the full production version of it since we would be exposing internal information. But this is just a limited version of LenAI with the limited set of tools that we have in production. I'm using the serverless endpoint that we have exposed. So it's our Solar adapter right on the serverless endpoint that Predabase exposes. And I'll just kind of walk us through a couple of use cases, a couple of tools. So we have the large language model itself as a tool, and kind of show the use case. We also, as part of the response, show why we chose that specific tool. Another tool that we have is the calculator tool. So we say, like, I can say, like, what is the square root of 64? And this should choose the calculator tool and give me a response of 8. And then finally, and this is probably my favorite tool since I work in architecture, let's see, we have a diagram builder tool. So what I'm going to ask it to do is give me an architecture diagram for a application called LenAI that integrates with 2 services, OpenAI and Predabase. And let's see how good it does. It should call our diagram builder tool and give me a diagram. Let's see how good it does. And this is the diagram that gives out. And it looks like it actually did a better job than I did kind of walking through the use case. But this is kind of this, we kind of started with Upstage's models with Solar Mini to kind of get this POC up and running and then kind of move this into production. This is essentially what started our journey with Predabase and our partnership with them. So.
Whoops, lost my everything. Awesome. Love it. The best performing SLM plus an organization that's doing GenAI at scale, seeing it come together. We have probably a minute or two for questions. Let's see what the audience was asking. Somewhat simple questions. You know, does document extraction work with PDFs, Word docs, PowerPoints, images, all of it, or any limitations?
Sure. I think most of the documents that you can think of course.
Nice. What is like your most like common use case? You guys have some big customers, I know, because we work with you and we've seen some of the awesome customers. What are the most common use cases that people are using your solar models for?
Insurance claims processing is definitely one. We call it info extractor inside. And then Info Finder, as we call it, you can imagine enterprise search, RAG. RAG is a method, but still, a lot of people want to index their documents to ask questions towards those documents.
And then Sid, you've used the Solar models. What is your what's your favorite thing about them?
I think so the initial way I went with the Solar was because we kind of saw that big headline of like the most fine-tunable models there is in terms of like they're the best performance when it comes to fine-tuning. So that's the initial reason why we chose them. And then we actually ended up benchmarking essentially our internal tool router. We built an adapter with Llama 3.8 billion, and then we built another adapter with Solar. And then Solar actually ended up outperforming all of the adapters we had in terms of accuracy. So just I think just how accurate it is and how well it performs compared to its weight class is probably one of the favorite things about that model. It's pretty performant.
Awesome. And maybe one more question, because there's been a few questions about sort of like performance hallucinations and mitigating that. Lucy, since you're like overseeing products, how do you think about mitigating against hallucinations when you're training a high performant model?
Yeah, actually, we still observe a lot of hallucinations. We actually tried to solve that with the model itself, Solar, but we don't think it can be prevented 100%. So we actually built another module called Groundedness Check. We uh, recently started calling it fact check. So it's very hard to define facts, but we consider internal documents as our fact source. So if we check whether these answers are complied to the facts within our organization, and that is one of the ways that we try to prevent hallucinations. So if we detect hallucinations, we run the pass once more, probably with another run or probably with additional information. And that is how we try to tackle the problem.
Awesome. And then of course, fine tuning can help with that. And then
Of course.
we have some of the other speakers here from like Galileo and Guardrails, who you have some great technologies too, in addition to the work you guys are doing. So that wraps it for time. Thank you guys for sharing that. A lot of people who are interested in the models. Check out their website. And then the Upstage team will also follow up if we didn't get to your questions, but feel free to reach out as well if you're interested in trying the models. As Sid shared in our experience at Pertabase, this is one of the best performing slims out there, and they're also just a wonderful team.